Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. Problem number 2300. Successful pairs of spells and potions. So let's read the problem statement. You are given two positive integer arrays, spells and potions of length n and m respectively, where spells of I represents the strength of the ith spell and portions of j represents the strength of the jth portion. Alright, you are also given an integer success, a spell and portion pair, right? Success and portion pair is considered successful if the product of their strengths is at least success, right? So pair of spell, right? Spell into portion, if I do right, spell and portion pair is considered successful if the product of their strengths is at least success, right? So product of them, it should be greater than or equal to success, this success, right? So now this is successful, right? So the pair of this spell into portion, the product of this is considered successful if the product of their strengths is at least success or greater than success, then also it's fine, right? We have to return an integer array pairs of length n, right? N is also the length of spells, where pairs of I is the number of portions that will form a successful pair with the ith spell, right? So that simply means that we have to iterate over all these spells one by one. So for this one, how many portions are successful, right? For this one, how many portions are successful, right? For this one, how many portions are successful, right? So we have to iterate over all these spells one by one, and then for each spell we have to find out how many portions are successful, right? So I can do one thing here, right? So I can sort my portions array, right? So if I sort my portions array, it is going to look like this only, right, in this case. But if you see in this example number 2, it is not sorted, right? So after sorting, it is going to look like this 5 8 8, right? So now here, once I sort, right, once I sort, so here what we need, spells into portions, right? So first let's say 5 into 1, if I do, so I'm going to get 5 only, right? 5 into 2, if I do, I get 10. 5 into 3 15, 5 into 4 20, 5 into 5 25. So here see, success is 7. So how many values which are greater than 7 here? 4, right? So 4 pairs are successful, right? This is what we are doing. Then we have to check this 1. So if I do the multiplication of 1 with 1, then 2, then 3, then 4, then 5, I'm going to get something like this. So none of the values are greater than 7. So 0 pairs are successful, right? So here we are adding 0 in the output. Here we are adding 4. Now for this 3, if I do the multiplication with all these portions one by one, so I'm going to get 9 12 15, right? Only these values are greater than this success. So 3 pairs are successful, right? So here I'm adding 3, right? So this is clear, right? What we are doing, right? Clear, right? So here, right, so if I sort this, right, what is the use of sorting? So if I sort this, so whatever the first value, right, here if you see 3 into 8 5 8, so here this is success, this is success. But if I sort it, then I'm going to get values like this. 3 into 5 is 15, 3 8 24, 3 8 24, right? So here all the values will be in increasing order only, right, starting from here, right? 16 is a success, right? So this is the first value which is greater than 16, right? So after that, all the values will also be greater than this 24, right? 20 will be equal to 24, greater than 24, because I have already sorted these portions, right? And if you see the portions, right, these values, so these values are always starting from 1 only, right? No negative values, right? Okay, and since portion is already sorted in increasing order, we are always going to get increasing order. So if I know this value, so I will say that all these values will also be success, right? Will also be successful, right? If I do the spell into portions, right? So that is the purpose of sorting here. That's why I'm doing sorting here, right? So once I do the sorting, then it will be very easy, right? I can simply apply the binary search on my portions, right? And I will find out the first value with which there is successful pairing between success and portions. So if I find that, so let's say if I find this here, right, then after that I will just find out the total number of elements in this range, and that will be my output for this one, right? So I hope that this is clear, right? And if you see the constants, n is nothing but space dot length, and our answer should be also for n size, right? And m is portions dot length, which we are sorting, right? So we are going to do the sorting on this, and then we are also going to apply the binary search. right, on this, and n and m value is from 1 to 10 to the 5, and that's it, and success is 10 to the power 10, right? Okay, so this is clear, right, what we need to do, so why we are doing the sorting, right? So now after this let's see how I'm going to do that. So here, spells into portions value, right, it should be greater than equal to the success value, right? And here the position, this portions value, right, I can say this value should be greater than equal to success minus spell, right? Okay, so here in Java, right, in Java, let's say your spell value is 5, right, your spell value is 5. So here in this place I'm writing 5, let's say, and here success, this success value is 7. So 7 divided by 5 in Java, you are going to get 1 only, right? Here you are going to get 1, right? If I just do the real division, so then in that case what is going to happen? 5, and here I'm going to get 2, then here point 0. So if I do the real division, right, then I'm going to get something like this, 1.4. But in Java, right, we are just going to get 1 only, right? So I need the, if I just use this one, right, if I just use this one, so it is saying that we have to find out the min portion which is greater than equal to 1, but this 1 is not valid, right? 5 into 1, if I do, I'm going to get 5 only. So here I need the seed value of this one. So 1.4, no, I'm going to say I need 2 here. I need the seed value of this one, right? This is in double format, so I need the seed value of this one. So here min position comes out to be 2 now, right, if I use the seed value. So if it is 2, right, so in the portions I will search the first value in my position which is already sorted, which is greater than equal to 2. So this is greater than equal to 2, right? This is the first value, right? So if I find this value, right, then my result is going to be the total number of values in my portions, let's say m is equal to 5. So 5 minus the index, at which index we have this, so 0 1. So 5 minus 1 is 4. So 4 values are possible, right? 2 3 4 5. So that is why I'm going to do seal, right? So I hope that this part is clear. So you can do the seal, right? Or you can also there are two ways to do this, right? So one is you are calculating the min portion, right? So I write your min portion value, right, portion value, or you can say here min portion value. I am saying that this value should be greater than and here you are writing success, and here you are writing spell, right? If you see here min portion, success and spell, right, this. So here one way to do this, right, so we know that we need to use double, right? So you can use like this. So first double of success, right, and spell, whatever the value you are going to get from here, right, you, this is in double only, right? So then we have to take the seed of this math dot seal, right, math of seal of this value, right? And let's say I'm changing it to long, it may be very big, right? So this is the one way to get this min portion in Java correct value. Or you can also write this same thing, right? If you don't want to use this seal, right, you can also write it like this: in the success, right, if you add the spell and subtract 1 from it, right, and then you do the spell, then also you are going to get the correct value. Why I'm saying that? So here let's say same example, 7 divided by 5, you are going to get 1.4. In Java you are going to get 1, right, if you just do this normal process. But now in this 7, if you just add the spell, 7 plus 5 minus 1 is this spell minus 1, right? So then you are going to get 11 and here 5. So now you are going to get correct 2 value, right? 2 value. Okay, so here clear, right? This is clear. Why I'm writing spell minus 1, why I'm not just writing spell, just spell? The reason is, let's suppose 5 divided by 5, this complete, right? So you are going to get 1, correct? But if you add 5 plus 5, then divided by the 5, right, this is spell, this is success, so you are going to get 2, which 2 is incorrect, right? So that is why here instead of 5, if I'm taking one less value, 5 minus 1 4, right? So 9 divided by 5, so again I'm going to get 1 only. So both are correct. So 5 by 5 is also correct, and 9 by 5 is also correct, right? So you can use this, or you can use this seal. So I hope that this is clear, right? So this is nothing but, this is concept is nothing but, you can say sealing division. All right, so this is one thing, important thing. Then after that, once I get this value of min portion, then what I will do, I will search for the index, right? I will search for the index. So let's say I'm going to apply the binary search on my portions array, right, which is already sorted, and here I'm just going to call min portion. So in min portion I'm just going to this index is just going to search for the first portion which is greater than equal to the mean portion, right? First portion in the portion array which is greater than equal to this mean portion. So now how this binary search is going to work, so let me prove that as well. So this I think you already guys are already clear. So let's say we have these many values, right? And I'm searching for 2, right? So how the binary search works, so we are going to take this as our low, this as high value, right? And then what we do low plus high divided by 2. But sometimes if these indexes are very large, right, these values, right, these indexes are very large, so sometimes we get integer overflow error. So in order to avoid this, sometimes we use this low plus high minus low divided by 2. So you can use any one of them. If this is working fine, okay. If this is not working fine at the top one, then you can use this one, right? Your choice. All right, so then this is how we calculate the mid, right? This is nothing but mid, this way or this way, you can use anything, right? So whatever is working. So here mid, here if I just give the index in 0 1 2 3 4, so mid is nothing but your 0 plus 4 divided by 2, 2, right? So mid is 2, mid is 2, right? So this portions array is already sorted, right? So mid is 2, right? Now if you see this value 3, right? Portions, right? Portions, this mid, which is nothing but 2, that is nothing but this 3 value, portions of mid. This value, if you see, if tell me this is less than my mean portion, no, right? This is not less than my mean portion. Then what is going to happen? Then in that case, this mid value, my high is going to become this, you can say mid minus 1, right? You can make it mid minus 1, right? Mid minus 1. So now this is going to your high, new high. Then again you are going to calculate 0 plus 1 mid, 0 plus 1 divided by 2. So 1 divided by 2, you're going to get 0. So this is going to become your mid. So now in this case, the portions, this value is smaller than the mean portion that we are searching. Then low is going to become mid plus 1. So then low is going to become this mid plus 1, that is nothing but 1 index, right? So low is going to become 1 index. And now if you see low is this and high is here, then next time again you are going to get this as mid. So again after that your high is going to move here. So once your high becomes less than low, then in that case you have to just simply return the last low value. This is how it is working, right? So binary search is very simple, right? Here we have low, here we have high, we calculate the mid. So if value is in this side, so we are going to search in this range. So again we are going to calculate mid. So again let's say this is my low, this is my high, again we are going to calculate the mid. So let's say mid is here this time. So if this is the case, then my low is going to start from here and my high is going to remain here. Then again we are going to calculate mid. So we have to do this until my low is less than equal to high, until then. So if this condition is not satisfied, then in the end whatever the low value, I have to return that. Okay, so very simple. When I'm going to write the code, then you guys will get better understanding. We have solved many problems related to this binary search. Okay, so let's write the code now. That's it. Okay, so here what you need to do now, let me just maximize the screen here first. Okay, right. So now here you have to write first sorting, right? Important, arrays dot sort. We have to sort the portions, right? portions, okay, portions, right? And then n is nothing but the spells dot length, and m is nothing but portions dot length, right? And our result is going to have the same length of spell. So int result is going to be new int n, right? Here we have to run one loop. So I'm going to write int I is equal to 0, I is less than n, and I plus plus. And here after this long spell is equal to spells of I, right? So this is what I'm getting. And then after that I have to find the minimum portion strength required, right? Minimum portion strength required, right? So here you have to just simply write a long, right? You can solve it this like this. Okay, let me use this one. Long min portion is equal to, here you have to write success plus spell minus 1, and then you have to divide it with a spell, right? This is nothing but ceiling division, right? Ceiling division, right? And let me add other way also to do this. So let me just copy this now. So this long min portion is equal to, and here you have to write long whatever the result, we have to change it to long back, and here we have to apply math.seal, and math.seal when we are going to apply, so it will be on double. Okay, and after that here we have success, and success divided by spell we have to do, and that's it. Okay, so success divided by spell, we are going to get something in double, right? We have changed it double, and then I am just going to do the math.seal of this, and whatever the value I'm going to get, I'm just changing it to long back. That's it. Okay, good. So this two ways, right? So you can use anything, right? Then we have to apply the, we have to do the binary search, right? Binary search for first portion which is greater than equal to main portion, right? So here int index is equal to binary search, and here you have to write portions, and here you have to write main portion, right? And the number of successful pairs, number of successful pairs is equal to remaining portions, right? So here what we have to do, we have to just update my result of I value is nothing but m minus I, right? M is nothing but length of portions, and I is nothing but index, right? Index, right? Done. And here after that we have to just simply return the result, return result. That's it. Okay, and now let's write the code for binary search. So we have to find the first index where portion is greater than equal to min portion, right? So here private int binary search, and here int portions, and here long main portion, right? And here after this you have to take low as 0, high as portions dot length minus 1 last index, and here you have to run one while loop while low is less than equal to high. Then here you have to calculate the mid. So mid is nothing but you can say low plus, and here high minus low, and here divided by 2, right? So this is done. And here if portions, right, if portions of mid value, if it is less than min portions, right, min portion, then in that case we have to just update my low as mid plus 1, right? Then we have to go to the right side, otherwise we have to check in the left side. So high is nothing but mid minus 1, right? So in the end you have to simply return low. That's it. Okay, so now let's run it and see. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.